Elon Musk has always invested in game-changing tech for Tesla, if it proves truly useful. And nothing has delivered like the GigaPress. The 6,000 and 9,000-ton versions already revolutionized production. Now, the 50,000-ton GigaPress is here, capable of building 12 cars every 60 seconds. Musk confirmed it, and soon, new models will fly through a line so fast, it's almost untouchable. So how does it work? And is this the future of car manufacturing? Let's find out. What many don't realize is that the journey of Elon Musk and the Tesla GigaPress is anything but ordinary. Getting this machine into Tesla wasn't simple. The spark came from an unexpected moment. Musk was holding a die-cast toy car on his desk when a thought struck him. Why can't we do this with real cars? That idea led to a game-changing vision, casting massive components like the entire underbody of the Model Y to cut down weight, cost, and build time. At the time, Tesla was under immense pressure to ramp up production of its bestseller, the Model Y. Cutting costs became a top priority, and the GigaPress looked like the ultimate solution. It had the potential to slash vehicle frame manufacturing costs by 20 to 40%. But there was a catch. No one had ever built a machine like this in the auto industry before. Die-casting manufacturers were skeptical, questioning whether it could even work. Back then, car makers relied on steel stamping and robotic welding, a process that demanded hundreds of parts and countless intricate steps. Even with the machine's promise, Elon Musk reached out to 6 major die-casting manufacturers to explore the idea. Shockingly, 5 of them turned him down, calling it unrealistic and impossible. It felt like all hope was fading. But then came a twist. Idra, an Italian die-casting specialist, said yes. Or rather, maybe. For Musk, that maybe was everything. To bring the GigaPress to life, Tesla teamed up with Idra and spent over a year in intense collaboration. It was no easy ride. Tesla kept requesting design changes, and Idra had to constantly adapt. One Idra representative recalled how their engineers had to work non-stop with every tweak Tesla suggested. But in the end, they made it happen. The 6,000-ton GigaPress rolled out first to craft the Model Y's rear chassis, followed by the 9,000-ton version for the Cybertruck. Now, Musk is charging ahead with the 50,000-ton beast, built for the Cybercab and the much-anticipated Model 2. Compared to the 6,000-ton and 9,000-ton GigaPresses, this new machine is in a league of its own. It can cast multiple frames at once, cutting casting time from 70 seconds to just 5. Sounds unbelievable? We thought so too, but it's real. It could soon build a full car in under 5 seconds. One every few seconds. That's insane. And hey, why stop? 50,000 tons? Let's go. But how massive is this thing? How long to build it? What really separates it from the others? And how does it manage to produce a Cybercab every 5 seconds? 12 per minute? Those were the questions swirling when Musk mentioned the 50,000-ton GigaPress. Many still confuse the tonnage with weight, but it refers to pressure, not mass. Even so, the machine's actual weight could exceed 3,000 tons, or about 6.66 million pounds. To put it in perspective, the 6,000-ton GigaPress weighs about 430 tons, or 948,000 pounds. While the 9,000-ton version comes in at 688 tons, or 1.52 million pounds. The 50,000-ton giant, it could reach a staggering 8.16 million pounds. A true beast, it generates 8.3 times the pressure of the 6,000-ton press and 5.5 times that of the 9,000-ton model. Installing it alone could take months. Its size? 131 feet long, 42 feet wide, and 39 feet tall, like a 4-story building tipped on its side. To house it, Tesla had to build a special facility with a deep, reinforced concrete foundation. And for comparison, the 6,000-ton version is already massive at 64 feet long and over 17 feet tall. So this one is on a whole new level. As for how it works, the 50,000-ton GigaPress uses extreme pressure to push molten aluminum into every detail of the mold, creating a perfect cast. Then the part is evenly cooled to harden into shape. The timing must be exact. Too fast, and air bubbles form. Too slow, and the metal begins to solidify mid-fill. The cooling stage is tightly controlled by a uniform system to ensure each part achieves maximum strength and precision. Once cooled, a robot removes the part, trims excess material and sends it off for inspection. The GigaPress is key in reducing vehicle weight, boosting structural integrity, and enhancing performance by casting one large piece instead of welding many smaller ones, saving both time and labor. Today, several suppliers offer Giga casting tech, and it's not just Tesla anymore. Companies like GM, Hyundai, Volvo, Zeer, and Xpeng are stepping in. Xpeng notably investing in a 16,000-ton machine. Still, the 50,000-ton GigaPress operates much like the 6,000 and 9,000-ton versions. It all begins with material prep. Tesla melts aluminum ingots and leftover scrap in a furnace heated to 850 degrees Celsius. After removing surface impurities, the molten metal flows through heated pipes into a sealed holding furnace kept between 750 degrees Celsius and 850 degrees Celsius. This two-furnace system, one gas-powered for melting and the other electric for holding, keeps everything at optimal temperatures. As mentioned earlier, the empty space inside the holding furnace is filled with nitrogen gas to prevent oxide formation in the molten aluminum and to keep the temperature stable. Operators also use argon gas, a rotary degasser, and a silicon carbide filter to eliminate any remaining impurities and particles over 25 microns. That wraps up the material prep stage. Now, it's time for mold preparation. Before each casting cycle, the GigaPress sprays about 35 milliliters of soybean oil onto the mold, like greasing a baking pan, to ensure easy release. A vacuum removes trapped air and molten aluminum flows from the holding furnace into the shot chamber. A high-speed piston, lubricated with 8 milliliters of oil, injects the metal into the mold. In a single unit, up to 5 parts might be cast at once. The challenge lies in scaling, managing hot liquid metal, fast cooling, and fully automated part removal. Once injected, the aluminum solidifies inside the mold. It's released at 400 degrees Celsius, then plunged into a cooling bath, dropping it to about 50 degrees Celsius. This rapid cooling boosts material quality. The mold is cooled to 185 degrees Celsius, cleaned by a robot, and prepped for the next cycle, which starts 1 to 2 minutes later. Excess metal is trimmed and recycled, and the final part is X-rayed to ensure structural integrity. One of the toughest challenges in this process is keeping the mold from bursting open under the massive pressure of molten aluminum injection. That's why the machine has to apply an incredibly strong clamping force to keep it tightly sealed. And when it comes to the 50,000-ton GigaPress, that clamping force is enormous. You've got to slam in the liquid metal and cool it down. Fast. Really fast. According to Elon Musk, making all of this work required Tesla to engineer an ultra-fast cooling system, a smart mold release setup, and an AI-driven automated quality inspection process, a tech trio no other automaker has dared to use at this scale. It also marks a turning point for the auto industry, shifting toward a production model that mirrors electronics manufacturing. Fast, streamlined, and space-efficient. Thanks to the one-piece casting process, car production has become dramatically simpler. Tesla's productivity has doubled and costs have taken a sharp dive. A production line that once needed 1,000 robots now runs with just 300. We believe the 50,000-ton GigaPress is set to spark a major revolution in Tesla's new lineup, making production faster and far less complex. Ironically, the GigaPress was once laughed at by the auto world. Critics called it impractical, arguing that aluminum molds wear out faster than steel stamping dies, driving up long-term costs. But Musk and Tesla proved them wrong. It's no surprise that Ford, Hyundai, Toyota, GM, and Volkswagen have now invested in GigaPresses of their own, all seeing firsthand how much Tesla is gaining. Producing 12 cars a minute, or 720 per hour, is rewriting the rules of car manufacturing. And this perfectly lines up with the Model 2, which Musk confirmed will reach production volumes greater than the combined output of the Model Y and Model 3. Now, switching gears to some recent updates, Waymo has halted its autonomous taxi services in parts of Los Angeles and San Francisco following violent protests tied to the Trump administration's immigration crackdowns. Things took a dark turn when several Waymo robo-taxis were vandalized, 5 damaged and 1 completely torched. The burning vehicles released toxic lithium-ion battery smoke, prompting police to warn people to steer clear of downtown. Considering each car costs between $150,000 and $200,000, the damage wasn't just physical, it was expensive. Meanwhile, over at Tesla, the robo-taxi rollout is heating up. A recent video on X gave us our first real look at Tesla's autonomous vehicle in action, driverless and gliding through Austin streets. It's expected to launch this month with a major event set for the 12th. Tesla seems to be reaching an impressive level of reliability, and by next month, even more customers will get a chance to test this game-changing service. What's your take on the future of self-driving cars? While that unfolds, here's something else. Tesla's Model Y just claimed the top spot as China's best-selling SUV in May, with 24,770 registrations. It edged out the BYD Song Plus and Geely's Jingu L. Despite a 71% drop in Tesla's Q1 profit, the Model Y's performance told a different story. From January to May 2025, Tesla sold 126,643 Model Y units in China, outpacing the Song Plus and Song Pro. That's no small feat, especially for a premium vehicle competing with more affordable options. Still, it's not all smooth sailing. Tesla's total sales in China for May hit 38,588, a 30% dip from last year. And the year-to-date figure stands at 201,926 vehicles, down 7.8%. But much of that slowdown came during the shift to the new Model Y earlier this year. With that transition behind them, all eyes are now on Q3 and Q4 for a strong rebound. What Tesla is doing with the Cybercab isn't just removing the steering wheel and pedals, it's reinventing car manufacturing itself. It's not just a vehicle redesign, it's a complete rethinking of the production line. Instead of a traditional assembly line, it's a network. Instead of human labor, it's robots. And instead of hand-assembled parts, it's stacking pre-made modules, like Lego bricks, exactly as Elon Musk described. It's the same idea used in small-scale castings, like making 100 Matchbox cars at once, just scaled way up. As Musk put it, they've built a cathedral of casting. In fact, Musk compared building the Cybercab to making toys. The only difference is Tesla's scaling the tech to produce as many vehicles as possible. Once 5 Cybercab chassis are cast, they move straight into the unbox line, a process so fast humans can't safely go near it. Casting 5 bodies at once means a much larger mold and a far more complex process. The molten metal has to travel longer distances, raising the risk of defects. Inject it too fast and air bubbles form. Too slow, and the aluminum starts to solidify before the mold fills. All of this happens inside a 50,000-ton machine. Naturally, Tesla needs time to transport, install, and fine-tune the GigaPress before it goes live. Seeing Tesla's leap with this streamlined production model, automakers like Toyota, GM, Geely, Volvo, and Hyundai are trying to catch up. But most are just starting, with 6,000-ton machines. So, if Tesla already has the 50,000-ton GigaPress in motion, the real question is, how long before the rest can close the gap? Thanks for watching. If you enjoyed the video and want more exciting updates on Tesla EVs, hit like, share, and subscribe. Don't forget to turn on notifications so you never miss a drop. See you in the next one.